Oh, hello everyone. Welcome to the 19th Ode aan the Code. And if I remember correctly, this is the second digital one now. Um, well, I saw a comment with someone asking if we could do it in English, so I'll try my best to do that. And here we go. First, we'll have two talkers today, speakers, I'm sorry, two speakers today. The first one is Pim. He's going to talk about final class aggregates, about placing rules and behaviors at the place that holds the data. He'll tell you everything you need to know from value objects to services and everything around that. After that, we have a small break, 5 minutes, so you can grab a drink or go to the toilet if you have to. Make sure to turn off your camera if you do, or anything like that. And after that, we have Joop, who's going to talk about improving your team synergy with the attitude model. He's going to explain how to argue within your team, and he's going to help you understand what everyone needs from their team to excel, and how they can leverage their skills to bring something new to the table so your team can excel as well. Um, well, I'm just going to pass along. Pim, you're up. Good luck, and well, talk to you later.
Guten Abend, meine Damen und Herren. Very nice to, well, not see you all this evening. I can see your questions in the chat. So if you have any questions while we're going forward, please just post them and I'll try and get to them as soon as I can. There are three kinds of people when they see this opening slide. The first kind will see, what function exactly of an is the aggregate? And if you're that kind of person, then just shut off the stream now. Just get out, come back for Joop's talk. I don't even want you here. Now, a normal person might say, what exactly is the function of an aggregate? If you're somewhat like me, then maybe you'll see it in this voice. Tell me, Harry, what exactly is the function of an aggregate? Or as it was in the movie, a rubber duck. This is a movie scene from Harry Potter, a movie I very much enjoyed when I was just a little bit younger. And what stuck with me from this scene is not so much the rubber duck thing, because as developers, of course, we all know exactly what the function of a rubber duck is. You talk to it. Now, what was interesting for me is that word exactly. Tell me exactly. Give me this exact specification, definition. Tell me, Harry, what exactly? Now, I've been doing DDD, domain-driven design talks and workshops for a couple of years, mostly focused on little things that you can do, start using right away, tomorrow, little things you can do to make it better, to make your daily job just a little bit better. But it always comes back to that same question. Tell me, Pim, what exactly is an aggregate? So today, for once and for all, the final non-extendable definition of aggregate. So an aggregate is a pattern of encapsulation that prevents a legal application state by hiding information behind strict rules and behavior. Or in other words, it's a transactional consistency behind a transactional boundary. Yeah, if that was too fast, don't worry, we'll spend the rest of this evening diving into that. Aggregates really are just another way of making the incorrect inexpressible. If you happen to have catch my previous talk, then maybe you have already heard that phrasing a couple of times. Make the incorrect inexpressible. That really is what it all comes down to. Aggregates are a domain-driven design tactical pattern. A pattern meaning a common kind of solution to common kinds of problems. Aggregates in the line of value objects, entities, aggregate services, they are patterns that deal with identity, state, rules, and behavior, things that we run into while we're coding. Putting aggregate into the title of this talk was just clickbait in order to get you here. We are going to talk about aggregates, but today mostly is about rules and behavior at the information. rules and behavior at the information. Rules meaning state transitions that we explicitly disallow. Behavior meaning state transitions that we explicitly allow, that we support. Information being identity, state, data, anything we use to make those decisions. So today we're going to be talking about the need for information driving the design of our application, the low-level design of our application. We're going to discuss this in 3 parts. First, we're going to look at objects and messages. Then we're going to look at what context is. And finally, I'm going to share some heuristics. After the first part, objects and messages, you will know what an aggregate is. After the second part, context, you will know why we have aggregates and some alternatives, when to use them or not. And after the third part, heuristics, you will have some guidelines that you could memorize if you want to know how to use aggregates. So let's dive into objects and messages. This is a presentation on object-oriented programming. And you can't do a presentation on object-oriented programming without referencing Alan Kay. But I'm not going to do that today. We're not going to talk about him. All we're going to talk about today is that objects are little problem-solving machines. Programming is the art of problem decomposition and solution composition. When we as programmers are faced with a problem, we split that problem up into little problems, solve all those little problems using objects, and then we compose those objects to compose one big solution. Every object that we make plays its role in this solution. So how do these objects contribute to that solution? So this is how you would work with an object. You can send messages to objects and they can respond to those messages. When you send a message that may or may not have additional input, an object needs to verify if that message makes any sense. So it can not only do something with the message, it first has to make sure if that message is not in error. Once it's decided that this message makes sense, it can either change or return a value, or both, but we don't really talk about that. So these rules that I mentioned make explicit what kind of messages our objects accept. And this behavior that I mentioned is making explicit how the system responds to messages. Domain-driven design offers a set of patterns, tactical patterns, that we can use to deal with rules and behavior when we send messages to objects. Here's an overview of some of these patterns that I've talked about in previous sessions and that are, in my limited experience in my own bubble, somewhat known. Value objects, entities, and services. So from the context of identity, really only entities have identity. Only with entities can you point to one and say this one is unique compared to the others based not on its attributes, but on its reference identity. Value objects don't have identity. Value objects that share the same attributes are interchangeable, and services, given that they don't have any state at all, don't have any identity at all. Services can have collaborators, but a service having collaborators is called aggregation, and that's not a word I want to use in this presentation, so forget I mentioned that. Now, all of these objects have rules, and that's usually widely accepted. But I do get some comments sometimes saying, I prefer my value objects not to have behavior. So, can value objects have behavior? Should they have behavior? Let's look at a few examples. Here are some common patterns that you see where value objects have been used to solve the problem. Some of these come from our own code base. Some of these you will see at other places. The first one, some examples of working with dates. We can send messages to these objects getting the previous day, the next, or the previous year. We see some PSR7 working with requests. mind the with and not the set header. Value objects are immutable, so they can only return a new version. They can't change. They can only return new information. So they might return a copy of themselves, but just slightly modified. That means that value objects, in case you were interested, really do have query methods. Money was also a very favorited example of working with value objects. And all these value objects have in common that they have behavior. They do work for us. They're not just making the incorrect inexpressible. They're making the correct expressible. So should value objects have behavior? Yes, value objects have behavior. They don't just make the incorrect inexpressible. They make the correct expressible. Value objects solve problems. All the objects that we create are supposed to solve one of those little problems that we broke down from the major problem that we're trying to solve. So let's zoom in on this message that we sent to this object today. We send the message previous day. Now, languages aside, we can all kind of assume what that could mean. What could go wrong? Think for a second here. When we send the message previous day to this object today, what could go wrong? Well, quite little. This message doesn't have any further input. So the message in and of itself could be wrong based on the current state of the object. But just looking at the message itself, it's probably a good message. And with our familiarity with language, I think most of us will assume that this is a good message and that this will work. How about this one? This message is a little bit more complex. We have some input with this message. With day can mean a lot of things. It could mean day of year, day of week, day of month. Given that it's 32 and I picked it as an annoying example, it probably means day of month. And in that instance, the message with day of month and then 32, that's probably not a good message. But what information does the object need to tell? How does the object know that this is probably not a good message? Well, it can tell just from the message itself. There is no month that has a 30-second day. So this message, just on its own, is probably incorrect. So what should the object do? Well, it should reject this message, either by sending an exception, or perhaps could gracefully fall back to some default behavior, but it shouldn't just outright accept this message. How about this example? Well, this example is so clearly wrong. There is no day that we can reference by the sentence, my favorite color is blue. So this example is very clearly wrong. The object should fail outright of being instantiated here. So again, these tactical patterns, value objects front and center, help us to make the incorrect inexpressible. Whatever is not okay should not be able to come into memory. Still, we can tell from the message itself, from the input given, that this is wrong. Can we come up with a little bit more of a complex example? Well, sure. How about this one? Imagine we have an object that's responsible for tracking an amount of money, holding a balance. Imagine if we have a rule that says this balance must be positive. Now, when we try to subtract a given amount of money from this balance, then we can't just tell from the message itself if this is a good message or not. Because depending on the current balance, this might actually underflow and cause the balance to go negative, which means the balance should reject this message. So what kind of information does the object need to verify this message? Well, it needs the message and its input, but also the current state of this object. But still, the object knows enough to respond to this message. Let's make it just a little bit more complex. Let's say we have a meeting service, and this meeting service can receive the message, get current meetings. It can then give us, as a response, a variable called current meetings. Is this message sensible? What should the object do to respond to this message? Well, of course, that depends. If you've seen my previous presentation, you know that naming things is stupid and it always depends. However, if we just assume that I'm not tricking you this time, that current meetings really does mean we want a set of meetings that is current, then what this service should probably do is combine some sources of information. What does it mean to be current? What are meetings? This current is probably something to do with time, something to do with dates. Meetings is probably an entity that has to come from some source, maybe a database or a repository or something like that. So this service should probably combine those two and give us a sensible response. What's interesting is that this object itself likely doesn't have enough information to answer this question. Having all meetings in memory and then filter a select set from that giant set of meetings, it's probably a bit too much. So when it comes to information, objects can respond using various degrees of locality of information. So that could look something like this. From these examples, we could extract a model that could look like this. Let's say we have a degree of information that could either come purely from input and locality, or from the global scope of available information. Think for a second, take your time, take 10 seconds. Where on this scale would you place value objects, entities, and services? I would place entities somewhere here. Entities have some local state, but we prefer to keep them somewhat small because entities are supposed to be very simple to test. So entities will usually have very interesting messages going back and forth, hold some data for us, work with defined ranges and everything, but they have limited scope of information. Entities I would place here. Entities are like the epitome of localized information that we've talked about so far. Entities have a lot of local state, can have a lot of local state, and usually work with value objects to make sure that their local state is consistent. Services I would place somewhere here. They mostly work with information that is only available through collaborators pulled in from the global scope. Now, on this scale, I would place aggregates somewhere here. Aggregates are a pattern that help us to localize just a little bit more information. We can use aggregates to work with a couple of entities, rules and behavior, cross entity, but not so cross entity that they could be widely different from each other, or widely different, or we'd have to consider several hundreds or even thousands of entities. No, if we can limit our scope to a predictable small set of entities, then we can localize that information into an aggregate and make sure that those rules and behavior can be solved in the aggregate instead of in a service, because we prefer value objects over entities, over aggregates, over services for unit testing purposes. Value objects are easier to set up, are easier to test than entities, than aggregates, than services. So an aggregate would look something like this. We have a set of objects, and those objects together have an imaginary boundary. And that is what we call the aggregate. The aggregate is a boundary within which there are rules and behavior. And those rules and behavior are guarded by the root entity. The root entity is the only part of the aggregate that is exposed to the outside world. Only through the root entity can other parts of the system work with this aggregate. That doesn't mean that the root entity has to do all the work on its own. It can still use other entities and other objects to solve these problems, but the root entity is the only part of the aggregate that is exposed to the outside world. So working with an aggregate would look something like this. Say we have one of those services and it had to register an attendee for one of those meetings. Well, the service would probably have to get the meeting from somewhere. It would have to then send a message to that aggregate, and then the aggregate does all the work. It does all the checking, the validation, and then does the work to make sure that its state is updated. Afterwards, all the service is left to do is save this aggregate. Now, what's important to note is this aggregate is saved in a single transaction. That means it is so-called transactionally consistent. So that means that these rules and behavior that this aggregate verifies are verified very strongly. An aggregate is loaded and saved in one chunk. It's all or nothing. There are some rules for working with aggregates. So, for example, you shouldn't send mutable objects into an aggregate. So that means that instead of sending a message with a mutable object, we send a message for the aggregate to do something and let the aggregate figure it out. If we allow mutable objects to cross this aggregate boundary and go inside, and we still hold a reference to it, we could change it later, and we could perhaps break the consistency of the aggregate without the aggregate root being able to verify this. Only values go in. We also have no way of getting entities out of the aggregate. Only values go out. Again, if we would be able to get a reference to an entity inside the aggregate, then we could change it without the aggregate root being able to verify that the change we're making is not breaking the consistency of the aggregate. Now, there are several patterns of getting something out of this aggregate. So if you do CQRS, which I do not want to talk about today, I'm not that experienced with CQRS per se, so there are smarter people than me to ask about CQRS. But if you do CQRS, then probably you have separate read models to query for information if you want to know something about an aggregate. If you don't, then one way of doing it could be either just getting a read model directly from the aggregate or being able to get a read model version of the aggregate itself and get something from there. Both have advantages and disadvantages. But either way will work just fine. And also, if you want to update an entity, then there is no way of getting that entity and then changing it. Updates go through the root. The root object has to verify the consistency of the transactional boundary. So to summarize, only the aggregate root is exposed. Only values cross the aggregate boundary. Only values cross the aggregate boundary. No entities. So aggregates are a pattern that help us to localize more information so we can have rules and behavior tested before we have to resort to services. So that sounds really nice. Aggregates give us a lot of advantages. So why don't we do everything in aggregates? Well, I don't know if any of you work with something like Galera. We get some of these every now and then. Aggregates have some downsides as well. So first off, storing an aggregate can be quite complex. If the aggregate grows in the number of different kinds of entities, then storing an aggregate will also increase in complexity. If the aggregate grows in sheer number of objects, it will grow in complexity of storage. Now, that complexity of storage can come with different ways of locking. You can have optimistic locking for aggregates that I don't want to get into today. You can have all kinds of locking in your database system built in, like this one here. Because aggregate sizes tend to grow a little bit as you're working with them, the performance of the aggregate can really be a major downside. For every rule or behavior that you want to perform on the aggregate, the entire aggregate has to be available. The entire aggregate might have to be loaded. So some advantages, some disadvantages. Let's recap a little bit. Value objects help entities be consistent. Entities can be a part of a root, can be a part of an aggregate or the root of an aggregate. Aggregates offer us transactional consistency behind a transactional boundary, and services, if you implement it, can offer eventual consistency. The need for information drives the design. Another way of saying rules and behavior at the information. At school, I learned to create a database model and then a class model. And then at some point you integrate them and then you start crying because they don't fit. So you can't really do that separately. The need for information, that's what drives design. In order to perform rules, we need information. In order to perform behavior, objects need information. And that need for information, by the problem solving that those objects have to do, that's what has to guide our design. We have to give objects what they need for their behavior. So to summarize, objects solve problems, rules, and behavior. They need information in order to do that. That information can come from identity, from state, from collaborators. Value objects have no identity, but they do have state, rules, and behavior. Entities have everything. Aggregates group objects that are affected by rules and behavior together behind a transactionally consistent boundary. Services group objects that are affected by rules and behavior behind an eventually consistent boundary. So now that you have some idea of what an aggregate is, should you use them? Well, all these domain-driven design tactical patterns are choices. It's a choice whether or not to use them. And remember, we do prefer value objects over entities, over aggregates, over services for unit testing purposes. But all of these need to be manageable and feasible. So let's talk a little bit more about that in the second part. And if you have any questions about this first part, please ask them in the chat and I'll get back to them. The second part is going to be about context. We already talked about context a little bit. There are two kinds of in and output for functions: implicit and explicit in and output. And with the local and the global state, we already talked just a little bit about this. So let's look at an example of a function that doesn't just have in and output, but might also have some context and some side effects. Here is that get current meetings function of the meeting service that we saw before. This function has no input. Really, all it has is context. It gets context from one collaborator, and then again, and it gets some more context from another collaborator, and then combines some of those results, and then returns it. So how would we write a unit test for something like this? Well, a unit test could look something like such. So we have a meeting service that we give a dummy repository, and that we give a clock with a hard-coded set date. And then we plan some meetings, and then we get the current meetings, and then we verify that our expectation matches the result that came from this service. So this is doable, but there's a lot of behavior in this test in dummy code. But mostly it's a proper unit test. However, let's look at this example. Let's say we want to, again, register an attendee at a given meeting. This function has input, yay. It has some context to make sure that the meeting that we're requesting registration for actually exists. Similar for the attendee, does it actually exist? Similar for perhaps there already was a registration. Those are already three context accessors. Then we do some actual work, and then we have a side effect to store that actual work. How would we write a test for something like this? Well, if you have a better idea, please do tell me. I mostly get stuck with this, with using mocks or using more dummies. And the more complex the collaborating behavior becomes, the more complex our mocks or dummies become. So perhaps we could fall back to integration or database tests. Oh, there's a typo. I really don't like mocks, in case you hadn't noticed. Here's an example that I wrote earlier this year. This is 100% actual copy and paste live code that's probably still runs in the CI. I'm not sure. Maybe someone cleaned it up by now. This is real code. This is code I wrote earlier this year. It was for a legacy service, so yeah. But this is not the kind of code that you want to write in your tests. This is very complex code. It's very brittle. It's very tied to the implementation, very strongly coupled with the implementation. Oh, I don't know about you, but I really, really, really don't like these kinds of tests. Even if they have 100% coverage, I really, really, really don't like these kinds of tests. In fact, it's not really a heuristic, but it's a good slogan. Mock and spy, make me cry. I want to create tests for complex logic. I don't want to write complex tests. So why do these tests become complex? Well, let's see. So here is a histogram of how this interaction went. So we have some kind of handler. That handler is calling our service to register an attendee. That service then has to verify whether this meeting actually exists. It calls a repository, gets the meeting. Has to verify, does the attendee actually exist? Calls the repository, has to verify, is this not already a set registration? Call the repository. So it constantly has to coordinate work to repositories. And these repositories are pulling in context during the execution of this algorithm in order to make these decisions. So this meeting aggregate here is very small. It does almost nothing, and it means that the service makes all the decision. All the business logic is in the service, and that means that we have a shared scope between the business logic, all these decisions that are being made, and the collaborators that actually provide this information. That means we have to use mocks, stubs, or some other form of dummy collaborator. So this is very loosely coupled. It's somewhat anemic, but the incorrect is inexpressible, and that's good. But for testing purposes, there's something off, and that's called white box testing. The code that we wrote here sets us up for white box testing. It means we need to know what's in the box. What's in the box? We need to know what's in the box in order to write tests for it. So here we have a service function that it calls 3 repositories, it does some work with the meeting, and we get a result from there. But our tests need to know exactly what kind of messages will be sent outside of this box and how we should respond to those messages. We need to just know. So there is no explicitness for this context. We just have to know. And that's a little bit of a problem. It's not bad per se, but it's just unfortunate. So what would happen if we would pull more information into this meeting so that not the service, but the meeting could make this decision? What would that look like? Well, that could look something like this. We have a handler. The handler calls the service. The service still has to get the meeting, still has to get the attendee, but we pushed the registration information into the meeting. Now, of course, you can't do that if you have hundreds of thousands of registrations. But if you have 100, then that's very doable. And the effect on your implementation is much simpler. So what happens here is we still have a white box test for our service, but the service isn't really doing so much anymore. It's just coordinating. It's not doing any business logic per se. No, the business logic is in the meeting now. And the meeting, no context, no side effects. It's just input, output. So we don't have to know about its internals. We can just write tests for it on how it behaves on the outside. And we don't need to know how it behaves on the inside. So what we did here using this aggregate pattern is we made the context explicit. We prepared the context in the service, and then we can use this aggregate, given its context, to do the work for us. We only test the input and output of this aggregate. But as mentioned, aggregates do tend to become too large. So I don't want the message of this session to be do everything in aggregates. I want the message of this session to be rules and behavior team formation. So what can you do if you still want to write these good tests? If you have something that's complex, you want to write good tests for it, but it's not feasible to use an aggregate. Well, there is something intermediate. You could do it like this. Now, this is a little bit more complex. So let's go through this slowly. We have a registration handler. The handler calls the service. The service, again, gets the meeting, it gets the attendee to make sure that these objects actually exist. Instead of asking the registration repository for all kinds of information, it's loading an object that can satisfy that question for us. A simple object that's just meant for the purpose of this. It could be a loaded list of all the registrations. It could be a lazy loaded list. It doesn't really matter. We then create a context object or use case, or it doesn't really matter how you want to name it. It depends a little bit on the context. If you ask James Coplian, it's a context from the data context interaction pattern, which you can forget. If you ask the Ruby people, it's a use case. But it's an object that's just responsible for this situation. That object receives the context in its constructor, and then any further work that it further information that it needs to do its work in the one execute function. And then this object can again do its work without further context, without further side effects. So we can have complex business logic tested behind this black box, still have the service being a white box, but again, no business logic, only coordination. And this new use case object can do all the difficult work for us and still be a good testable object. We don't need to know how it behaves on the inside because it's not going to send any messages to the outside. We made the context explicit and prepared almost as if it were an aggregate. And all the aggregates that are still involved, which is just a meeting here and perhaps some registrations, are small. So implementing this would look something like this. We would have a registration service that instead of doing the work itself would load all the context, and then instantiate our use case object, and then run that use case object and save the result from it. Now, what's interesting here is what reasons are there for these lines of code to fail? If you look at the first two lines of code, the meeting and the attendee, the reasons why those lines of code would fail is probably something along the lines of a programmer error. Why is this function being called with a meeting that doesn't exist? Why is this function being called with an attendee that doesn't exist? It might be race conditions, but it could very well and quite often be a programmer error. But the register new attendee situation, that's probably a user doing something weird. So we split off the business rules from the technical rules. How would the context object look like? Well, it would just be a very simple object that only does these rules and then the behavior. Super easy to unit test. Unit test, proper unit tests. Now, this is obviously more work. You need several more objects for all of this. So you're not going to do this for every situation. So when would you use this? Well, I have a heuristic that I like to use. It's a heuristic we use for many things at our work, and it's one to many. One to many. Whenever you find writing the same thing more than twice, is do it properly. So instead of having several unit tests that do a lot, split them up, have some integration or database tests that make sure that the infrastructure works, and then have proper unit tests for all the complex business logic situations. What's funny about this is programmers, when they have to write all these tests, and I've done a ton of workshops with tests, so I see this behavior every time. When things get complex, these tests become more complex. And when these tests become more complex, programmers get frustrated. And when programmers get frustrated, they start to automate it. So they start to automate the test automation. And then the tests become more and more complex. And then when they have to make changes, they have to make weird changes all over the test, and it just becomes a big mess. So what's interesting is that domain-driven design is a approach of tackling complexity in the heart of software. And when I see these programmers making their tests more and more complex, they're actually hiding the complexity that is inherent in the domain. So the beauty of either using aggregates or using these context objects is we're making this complexity explicit. And if that's maybe the most famous domain-driven design slogan, as make the implicit explicit. So to summarize here, this is my view on whether you should use just a plain service, whether you should use aggregates, or whether you should use one of those context objects. If you want to go for performance, don't use an aggregate. If you want to go for convincing your coworkers that having more code doesn't mean having more complexity, then don't go for the service plus context. If you want to have many good unit tests for complex cases, don't stick with just services. So for most cases, just use the service. For transactional boundaries, if you have one of those beautiful business rules that really fit very well into just a little collection of entities, aggregates are a wonderful pattern for that situation. And if you have complex cases, make it explicit. So to summarize today, objects receive messages. The information that is needed to respond can come from the message itself, from the object's local state, or through collaborators from the application global state. The more information that is needed to respond to these messages, the more difficult it is to remain transactionally consistent. The domain-driven design patterns help us to make the incorrect inexpressible. Value objects and entities are mostly commonly referenced. People know about them, even though they have some misconceptions. Use them. Value objects before entities, before aggregates, before services. Aggregates are a tool to maintain transactional consistency. Services are a tool to maintain eventual consistency if you implement it. Services, and especially collaborators, suck for testing. So if you have a complex situation, you can use context objects to facilitate localizing information while still maintaining eventual consistency. These context objects will help you separate the technical concerns from the business concerns and make the complexity that's inherent in the system explicit. That was the complex part. I now just have a couple of heuristics, some thoughts that I find helpful. Let's see what you think. So heuristics are anything that provides a plausible, yada, yada, more guidelines than actual rules. Heuristics are useful. They help us to not think. Thinking is expensive, it costs us energy, so we really want to not think. We want to use all those biases, so we can steer our biases a little bit by thinking of these heuristics. They help us to make our biases perhaps a bit more productive. So first off, everything is a value object until it's not. We prefer value objects over entities, over aggregates, over services. Especially value objects are the most valuable tool of these tactical patterns, in my opinion. Aggregates guard transactional consistency. Services guard eventual consistency if you implement it. That means no aggregates, no entities cross aggregate boundaries No aggregates cross service boundaries. Because otherwise the aggregate and the service could not guarantee the rules. Programmers make theoretical rules. Programmers are usually not the people you want to decide on, is this an aggregate or not? Because programmers tend to be very much in the yes, but what if this actually happens and then that and that? Work with the business if you can. Keep aggregates small. The larger aggregates become, the more of an impact they will have on your persistence mechanism. Keep aggregates small. Push context and side effects to the edge of the domain. This makes your testing life much easier. And of course, finally, rules and behavior at the information. Now, I don't see any questions, so I do have a question for you. Tell me, why is there so much confusion about aggregates? Thank you. I'll just do a little dance until the organization wakes up.
Well, hello. Back again.
I'm still dancing.
Oh, okay. I'll just okay. Time for a small break. Thank you for your talk. I'll be sure to watch it back again to make sure I get everything. But it did sound really interesting, the service aggregates context, all that stuff you just talked about. And yeah, sounds good. Thank you. Time for a small break. Grab a drink, hit the break room, whatever you need. Normally, I'd offer you a beer, but well, since we're not in the office, I can't do that right now. Yeah, see you back soon.
Kijk. If you would just share my screen, then yes, very good. Welcome. My name is Joop Lammerts. I'm a colleague of Pim, so it's quite interesting that we both talk on this evening from Ode aan the Code. I'm not having any technical talk, so you just can lay back and relax a little bit. Normally, I start this presentation with a couple of questions, which is a little bit hard now. So hopefully all of you work in teams. Most of you have a little bit of frustration with your teammates, and some of you can relate to the following. Imagine this, that you are working on a piece of software and you think you're nearly there, nailing it, writing the most beautiful piece of software you've ever done. You're ready, you flip your keyboard away, you turn to your teammates, you yell, "I'm done, this is the best piece of software that I've ever written." And then they start testing and they're like, "Well, you forgot this little thing over there." And then you go like, "Oh no, I can fix that." And before you know it, the lights turn off, it's late, and you're still working with a box of pizza next to your desk. I hope some of you can relate to this story. If not, that's sad for me, because then I'm the only one. If you can relate to this story, please stay within this talk, because this talk might be for you. But first, I want to take you all back to 2008, to the Formula 1 Brazilian Grand Prix. The time Formula 1 even did do races, because, well, they don't do it as anything, and I'm sad about it. It was this particular year that Lewis Hamilton, driving from the McLaren team, could become world champion easily. He had the best car, he had the best teammate, which meant this teammate didn't win any races. So the championship was really for him to grab. But halfway through the season, he started to make mistakes. His car broke down a couple of times, and during this Grand Prix, the last one of the season, he found himself in the position that he needed to become 5th to secure his first world title. It should be easy, because like I said, he had the best car. Qualifying went great. He got the 3rd position on the grid, which meant perfectly well, because he needed to be 5th, so all he had to do was drive and finish the race. But on the day of the race, it started to rain. And if you ever want to see chaos happening, you should watch a Formula 1 Grand Prix, where minutes before the start it's starting to rain, because no one really knows what to do. Do we go on wet tires, on dry weather tires? Eventually they started on the wet tires, and Hamilton had a bad start, as you can see right here, because he is all the way in the back. He fell down to 7th place, which meant no world championship title for him at that particular moment. The track started to dry up, and eventually he overtook some people, and he found himself back again in 3rd place, and he was on his world championship course. At the end of the race, it started to rain again, and once again, Formula 1 will be in chaos. Do we go switch back again to the wet weather tires, or do we stay on our dry weather tires? The team of McLaren decided to put Hamilton on the wet weather tire. At that moment, he came out of the pits in 6th position, meaning no world champion. Just imagine that you are there at your office, writing your perfect piece of code, and your teammate says, "Well, you forgot about this," and you are like, "I can fix that." The lights turn off, and there you are all alone. I can imagine that's exactly what Hamilton felt those last couple of laps of this Grand Prix. All season long, he had there fighting for his world championship, and in the nick of time, you saw it losing him by 1 point. As the laps go by, he tried to overtake the guy in front to become 5th. Eventually, in the last corner of the last lap of the last race of the 2008 Formula 1 season, he overtook the guy in front of him, finished the finish line in 5th, and became world champion. Why am I telling you this? A year later, his team told him that they are on the other side of the globe, back home in England, And they calculated that if they switched Hamilton on the wet weather tire, he would eventually become 5th in the last corner. So the moral of this story is, trust your team and you'll become world champion. But like I said, I hope that most of you got a little bit frustrated by your teammates, because how can you trust your team if sometimes you get frustrated? So that's why we're here. You are the world champion, how to improve your team synergy with the attitude model. Now, the attitude model is, it's not a good model, like most models. It's a useful model, I hope. And we noticed, and me and Pim, we noticed this during the workshop we give at our intern colleagues. And we believe that there are two types of programmers, or maybe even two types of people. People who tend to be divergent and people who tend to be convergent. So we have this divergent people on one hand, convergent people on the other hand. But which one are you? So let's take a pop quiz together, and I have a few simple questions to determine if you are the divergent person or the convergent person. When you start a new project or a new feature or anything at all, do you want to work out some details and start coding to get a better understanding, or do you think out the big picture to get a better understanding? So A, work out some details, start coding to get a better understanding, or B, think big and work out the general picture. You have to choose one of those. If you are coding, I regularly throw code away and start all over. I only start coding when I see the bigger picture. Once again, please choose A or B just for yourself. All right, next one. I can easily talk and type at the same time. A is I agree, B is I disagree. So A, I can easily type and talk at the same time, or B is I can't easily talk and type at the same time. When someone shares an idea with me, I tend to get a lot of ideas of my own, or I see potential problems and risks. And it's the last one. When I face an obstacle, I tend to park it and work on something else for a bit, or sit down and get to the bottom of it. So these are a few simple questions to get a bit of an understanding on why on this scale of divergent, convergent you might be. If you have more A than B, well, congratulations. You are divergent. You are optimistic, you get a lot of ideas, you're eccentric a little bit maybe, so it's good to be divergent. If you have more B than A, you're convergent, which is also very, very good to be, because you can see problems and risk at a really soon during a project, and you can help others by pinpointing out, yes, sure, if we go that way, then somewhere along the line, somewhere there, we're gonna get into trouble. So to summarize, divergent people tend to be open, they're optimistic and curious, but they're also quick, sloppy, and careless. And you might recognize some of your teammates already in this. If you are convergent, on the other hand, you tend to be closed, a little bit pessimistic, and paced, delinquent, and careful. It's not bad to be any one of those. It's not good to be any one of those. We both need them. Inside your team, you both need the divergent and the convergent people to work together. And I'll be coming back to that one in a minute. There is a little bit of theory behind this all, and this is called the double design diamond, and you might have heard of it in the past couple of years. It focuses on this divergent, convergent type of thinking. You can split up developing software in a couple of phases. The first phase is we try to discover what we can do and what we might do. It's a little bit of problem discovery. What problems are there to solve? What problems can we solve? So the first part is what problems are there to solve for us as a team? What problems are there to solve for our clients and customers? If we have a big pile of problems, we can choose which problems we are going to solve during the next release, sprint, week, or whatever you choose to pick your work, to cut your work in little pieces. So you can already figure out that in the discovery phase, you need the divergent people to come up with ideas. But it's good to have some convergent people as well to tell you what ideas you shouldn't focus on and what not, because they won't solve any problems. Because divergent people get ideas and ideas and ideas and they go on and on. So you need someone who can put on the brake. In the second phase, we see the develop and the deliver stages. Once again, during the develop phase, we need to discover ideas and discover ways, solutions, how we're going to solve this problem. And eventually we need to deliver. So we need to choose solutions which we're going to implement in software. During these phases, you need to talk to your teammates. And if you are lucky enough to have a couple of divergent thinking and a couple of convergent thinking people inside your team, this will go real easy. But it can also be a little bit tricky, because if you don't know which type of programmer your teammate is, and you're on one end and the other one is on the other side, it can really get frustrating. I had a teammate once who was, I'm on the divergent side and he was on the convergent side. And the moment we started working together, he was always like, yeah, but this can go wrong and that can go wrong, and if we do that, then something might go wrong, and I don't know if we really need to do this. And I was like, yeah, dude, but we have to get started to make something. The week is almost over and we're not done yet. And that's the frustrating part. So we tried to work together, and I started a little bit off, like goofing off, and I got a little bit of ideas, and I started to code, and eventually he took over and fixed all of my mistakes. Mistakes like the things I didn't see, because I don't see the details that much when I start coding, because I get new ideas, and eventually I will fix them while coding. It's really hard for me not to see you, so I hope this will make a little bit of sense. Right now, I want to dive a little bit more into how I experienced this whole situation in my team during a sprint. And like I said, I am the divergent kind of developer, and I see a lot of possibilities, a lot of, I'm really open, I'm really optimistic, and I'm always like, I can fix this. So my team had this client, and we were onboarding them within our system, and they have memberships, and we modeled that as subscriptions. And we needed to import their current memberships into our system. And you can pay for your membership annually, monthly, or quarterly. And I was like, oh, I can do that. It's easy. I can fix that. Give me a day and I'm done. It took me 2 days because it was a little bit hard to do, but eventually 2 days I was done. And then my teammate said, yeah, but the quarterly memberships don't start always on the first month of a quarter. They can start on February and March as well and go for 3 months. And I was like, that's not a problem. I can fix that as well. So I started coding again, dived under, and 2 days later I came up and already it was first day of the week and I was like, I'm done. But then we really had hit the issue because our system needed to start those quarterly memberships on the first of a quarter and not during any other month. So we figured out on the first day that we needed to converse also this data into other memberships as well. And I was like, oh, well, I can do that. Every day, I can do that. and it was Friday and I wasn't done. I failed. I failed my team. I was like, I can do this. I dived under, came up 2 days later, thought I was done, but I wasn't. So if we take this situation of me during that week, and we put it towards this double design diamond and towards the attitude model, which once again is not a good model, but it might be useful. I didn't take any advantages of having a convergent member within my team. The only thing I did was divergent thinking. The only thing I did was coming up with solutions and just put on my headphones, dive in my computer, implement them, hoping to fix the problem. So I thought to myself, I can do better than this. I give workshops to people. I can do better than this, but how? So the next sprint, which was a week later, I still had to fix this whole issue of converting those membership data into something that our system can work with. And I knew that if I didn't take the advantage of my teammates, I would fail again. So instead of diving under every time I thought I had a solution, I faced the problem. I worked on it a little bit. As soon as I could, I would show it to my convergent teammate and I asked him, would this work? If I do this, would this work? And he knew exactly if it would or not. So I didn't go as fast as I could typing wise, because I can write a lot of code in a short period of time, but I knew I would make the right code at this time. Because every time I made a decision, I turned my desk or I turned my chair and asked him, is this the right decision to take? Is this the right path to go? And he said yes or no, and I fixed it. So this is what you need to do, in my opinion, if you have frustrating with your teammates. Try to figure out if they are the opposite of you, and maybe you should go a little bit slower and ask them for help. So what can you do tomorrow when you go back to your, well, not office during these days, but if you start working together again with your teammates? If you are coding together, be explicit on what you're doing. If you are discovering options, or if you are deciding what way to go, be explicit together to each other. What are we going to do? You can also try to do pair or mob programming. It's really with this model, and exactly especially if you have a divergent and a convergent developer in your team, it's really useful to do this. I would like to suggest to let the divergent developers start. They can easily get a beginning of the software. They can start easily. They have a lot of ideas. If you work in 25 minutes, every 25 minutes you can ask to each other, should I do a little more, or do you want to start working on the software that I've written? If you are in a meeting like a backlog refinement or a sprint planning or anything else, any meeting at all with domain experts, business experts, colleagues, whatever, once again, be explicit. Also work here in 25 minutes and set a timer, because you can step out of the meeting and think, are we still on the right path? You can use the double design diamond here perfectly. Explore, choose, and design everything within 25 minutes. So use 25 minutes to explore which problems are there for us to solve. Use 25 minutes to choose together which problems are we going to solve. And use 25 minutes together to design how you want to resolve those problems. And use 25 minutes, well, to figure out which solution you go to and implement that solution during your sprint. And you can even do this within every product backlog item. So this double design diamond, you can do it iteratively on every item on the backlog. And if you are modeling, once again, be explicit. You let the divergent team members think of options because they are really good at it. They excel at thinking options. Choose the most less bad option. It's not a typo. Convergent people tend to never see the perfect solution. It doesn't exist. So if the divergent colleagues come up with options, the convergent people can choose the option that is the best and not the worst, because the perfect option doesn't exist. If they think of options, they tend to think as long as needed to come up with the perfect option, which doesn't exist. But also learn and repeat the process. It's hard to do. So give yourself and your teammates time to do this. I really miss interaction with you guys, so I'm done a little bit fast because this was really the attitude model. If there are any questions, please ask them and I will talk about it as long as you want.
So, here we are again. I hope everyone can hear me this time. Yes, so that's good. Yeah, I grabbed a different microphone just to be sure. Well, thank you everyone for attending this Ode aan de Code. And well, I hope you learned a lot actually. I myself did. Apparently I'm a divergent person. No idea. But I am. And as it turns out, my team lead is actually a convergent person, so that's blends pretty well actually. Now it's really cool to know that you need both. Like, it's not a bad thing to be easily distracted and find different things and lots of different things. And it's also not a bad thing to have someone who just pulls you back and says, no, we're gonna use this, and stop looking. So that's really cool. Thank you very much for this talk, and well, hopefully see you next time.
Yeah, someone asked me to do a dance. No, I won't do that. I'm sorry.
All right.
Street the correct, so no.
All right. Well, I hope everyone has a great evening, and see you next time.